Hello and welcome to Pythagoras Theorem, Finding the Hypotenuse with Mrs. Kirby. Now, Pythagoras Theorem is one of my favourite bits of maths. Pythagoras was a very famous Greek mathematician who lived about 2,500 years ago, about 500 BC, and he was fond of drawing diagrams and working things out and then finding a rule for those particular things that he had worked out. So first of all, if I show you a triangle that he drew a triangle like this, and he found out that if it was a triangle with a right angle in, if you drew a square on this side of the triangle, which had the length the same as the base, so this was a square like this, and another square coming off here. Let's colour those in to make them different colours. Remember, he was doing this without any calculators or any sort of computer to work it all out. He was just using a ruler and probably not even a very sharp pencil, to be fair. And another square going off here. And he found out that then if you drew a square which also came off the longest side of the triangle, which is called the hypotenuse, this sloping side, the side opposite the right angle, and you worked out the area of that, then if you added the purple area and the orange area together, you would get the answer to be the green area. And what we can do is we can write this in symbols, so we don't have to keep drawing triangles the whole time. And as we get a little bit better at it, we can also use our calculators to do it so that we don't actually have to have whole numbers anymore. But I'm going to start off by looking at whole numbers first of all. So first of all, this is the hypotenuse. And that is the longest side in a right-angled triangle. And it's really important to have a right-angled triangle because Pythagoras' theorem only works if you have a triangle with a right angle in it. So this has got a right angle, and the right angle, the pointy bit of the right angle, always points towards the hypotenuse. The other two sides, it doesn't matter what we call them, so we're going to use two letters, A and B, for those, and it doesn't matter which way round they are either, so if you have them the other way round, this still works. And we're going to call the hypotenuse C, and that's how we always write Pythagoras' theorem. And if we think about how we find the area of a square, the area of a square is the length times the length, and because the lengths are both the same, that means that we are squaring the side length to find the area of a square. So we can summarise Pythagoras' theorem by writing the square on this side, or the area of the square on this side, a squared. If we add it to the area of the square on this side, the orange bit, b squared, that is equal to the area on the hypotenuse, which is this green square here. A squared plus b squared equals c squared. And this is Pythagoras' theorem, and he worked this out. And first of all, he worked it out with some whole numbers, some integers, and then later on he also did lots of calculations that showed it worked for all the triangles he could possibly work it out for. So I'm going to do an example with some numbers in a triangle to show you how it works. We're going to sketch a triangle. And when we're sketching triangles for this sort of work, we don't need to draw them to the proper dimensions. We can just draw a right angled triangle and fill in what the measurements are from the question. So I'm going to call this one 3 centimetres, this one 4 centimetres, and we're going to work out the missing length x. I'm going to use Pythagoras' theorem to do that. So what we do, first of all, is if we're doing the question on a piece of paper, we always write out a squared plus b squared equals c squared, or you can write it the other way round, c squared equals a squared plus b squared. It's entirely up to you. Both of those are perfectly acceptable. I actually always prefer to write the c squared bit first. So I'm going to write c squared equals a squared plus b squared. And then I am going to substitute my numbers in, and this is where you get the first mark in a question for putting the numbers in the correct place. Do not work anything out at this point. So my c is where my x is, so that's going to be x squared. that is equal to, we're going to call A, and this one we're going to call B. So at the moment A is 4 centimetres, so 4 squared, and B is 3 squared. So all we've done there is write a number instead of a letter. We've substituted the values in. Now we're going to do some working out. So the x squared just stays as it is. 14 squared is 4 squared is 4 times 4, which is 16. 3 squared, 3 times 3 is 9. So that means that x squared is equal to 16 plus 9, which is 25. Now, if we want to work out what x is, we have to have something that undoes a squaring, and the mathematical operation that undoes a squaring is a square root. So we are going to square root the x squared, and that will give us just an x. And we're going to square root the 25. So if we square root 25, we're asking ourselves what number, when I times it by itself, gives me 25. And the answer to that is 5, because 5 times 5 is 25. Now, if you wanted to check it in real life, you could draw a triangle which had 3 centimetres long here, 4 centimetres up here with a right angle in between them. And if you did that, you would find out that this long side, the hypotenuse, is actually 5 centimetres. And this is what Pythagoras found out. And this is called a Pythagorean triple because they are 3 whole numbers. I'm going to do another example which also has whole numbers. So a different triangle. I'm going to put it up a different way this time. It doesn't change what happens. First of all, I'm going to put the measurements in. So 5 centimetres, 12 centimetres and x. And then let's label up our triangle. I'm going to highlight the labels. Perhaps should have done that on the previous one. So let's go back and do that. C is the one we always label first. That's pointed to by the right angle. So this is C. And then it does not matter which way round A and B are. So I'm going to call that one A and that one B. And this time I'll use my highlighter and work out which one is which so they all stand out. Then we write down Pythagoras theorem again. C squared equals A squared plus B squared. Then we substitute our values in. So C is worth x squared. A is 5, so 5 squared. Remember, at this stage we don't work anything out, we just substitute the numbers in. And B is 12 squared. Then we do the working out. X squared is equal to 25, 5 times 5, plus 144, which is 12 times 12. Then we add the numbers together, so x squared is equal to 169. And remember, to find out what x is, undoing a square, we square root everything. So that leaves us with x is equal to 13, and I should have put my units on there, 13 centimetres. Okay, right, let me just go back through that one more time. This is a right-angled triangle, and it's called a right-angled triangle because it has got a right angle in it. The hypotenuse is the longest side on the right-angled triangle, and the corner of the right angle points to the hypotenuse. The hypotenuse in Pythagoras theorem is always labelled as C. The other two sides are labelled A and B, and it does not matter which way round you label A and B. So once you've got your question, the first thing you need to do is label up your sides with A, B and C. The right angle points to the hypotenuse and you label that C, and you always write C first on your diagram. Then you put A and B on, and it does not matter which way round A and B go. And then, as you can see here, I've used a highlighter, and that helps me substitute the numbers into the correct place. Write out Pythagoras theorem for each question because that will help you learn it. Then substitute the numbers in. Do not do any workings out at this stage, just substitute the numbers in. X squared is equal to whatever the value of A squared is, and in this case it was 4, added to whatever B was squared, and in this case it was 3. Then on the next line you do your workings out, you work out what the squares of those numbers are. To undo a square, you have to square root the total, and that would give you a measurement for your missing side, which is the hypotenuse. Same here. Substitute the numbers in, work out the squares, add them together, and then square root. You do not have to have a whole number. Sometimes the answer will be a decimal, and if you're being asked to do it on a calculator, you could have a decimal answer. So answer can be a decimal. Okay, thank you.